So, shall we see, are there any sort of, well, not sort of, are there any phase 2 questions that could possibly be left unasked by this point in time? It's due tomorrow, right? No, due tonight. Tonight. All right. All right. Yeah. Oh, so you're Brian's Benjamin's spokesperson today, I assume. No switching to football or anything more interesting. Else I'll send Ben out to tackle you. That is true. What are you going to do? So no phase 2 questions. Everybody's getting there. To test the Espresso Plus Plus, just grab the Espresso Plus Plus good test from phase 6. Yeah, we tried that yesterday, and that seemed to work just fine. And I think at least for all the good tests, the test all script or the Python script should be completely proficient to I think it's called test all, run all phase 6. Yep. So that's the case.
Yeah, the one was just fine.
Yeah.
For all bits.
Cool. Anything? No, nothing. So this was actually last chance to ask questions. Don't. Do we have a date for the final yet?
That's set forth by the university.
Yeah. I don't know if that. I doubt that the final is out yet, but we do have to figure out when to do a midterm. When do you want to do a midterm? Nothing yet. No. When should we do the midterm?
Nope, here it is.
Oh, there's something. So what do you think? Nothing.
It's a dead hybrid.
Oh well, there's nothing new there.
You can't. Oh, it's the Google for
whatever. So midterm. So what? How many weeks do we have?
It's December 7th at 6 p.m.
December 7th and at 6 p.m. Really? So does that mean that's a Monday?
Yeah, only 2 months away. No, that's a Tuesday.
The Tuesday. Oh yes, of course, it's a Tuesday. Sorry. Yeah. So that means I could technically leave the week before and do this from Europe. I might actually do that. So we're going to do we'll do the exam online as well as the midterm. Should we can set a date for midterm? So let me just pull up a calendar. So let's see, we've been here for 1, 2, 3, 4, 5 weeks. 5, 6, 7. 7, 8. So does that mean like the second week of October? Third week. We can do third week of October. What we could try to do is we could try to make it not collide with all the other courses as midterms. So I don't know if you all know when those courses have midterms, if they have any. So maybe we can tentatively say the third week of. Well, so the first week of October starts on a Friday. Is that how we calculate that, or are we talking about the first whole week of October? Because if we then want to go to the second whole week of October, we're going to be looking at something like either the 12th or the 14th. I think that might be okay, right?
I leave that Saturday, so helping you grade would be easy.
So you're gone from that Saturday, the 16th,
to the 30th. I'll be out.
Yeah, we got to do it before then. So could we maybe do the 12th? How about the 12th? Well, if it works for Brian, then it's fine. That's really all I care about,
We are not
That is right.
We front as a democracy.
That's right. I was about to say we pretend very much that you have a say in things, but it's
except for homework, you guys have all the control over
that. You should see him now. Anyways, let's hold on to the 12th. Can you make a note on the board somewhere just so I don't forget? But probably not where Ben is going to come in and delete it in a couple of hours. Not the 4th, the 12th. I don't know. The 4th is a Sunday. No, it's a Monday. Yes, probably.
I saw 4 on computer.
12th of October. All right, cool. Right, so let's hope let's see. And if you don't want to do the midterm, that's fine. Then your final will count for more. But it might be a good idea to do it anyways. At least it's a good practice, and at least because it's online as well, which is kind of silly. But
No, we don't do
why does anybody want to be locked down? Do we have to go over with handcuffs? I think I have a pair somewhere.
that. No, I mean the lockdown rounds.
Oh,
We don't do that.
no. And if we have to go lock people down, that's too many people. Others are saying the 477 midterm is on October 12th. Oh.
So it's easy.
We'll talk about it next. We'll talk about it later. How's that? But so it's going to be right around that time, I think. We can do the week before as well. So what is that? The 5th? Should we do the 5th instead? Yeah, we're not going to go all the way to the 21st of October because that leaves us just 4 weeks left, something like that. So the 12th or the 5th, those are the options. 12th or the 5th are the option. How about the 7th? Okay, fine.
You could.
I don't really. 7 is fine.
The
7. I have decided it's the 7th now.
The first or second week of October.
All right, it's the 7th. Right. So where were we last time? We looked at something that is a little hard to recreate now because I erased things as we went along here. But we looked at how it was possible to create a series of tables that I attached at various places where new scopes opened, and deleted at the points where the new scopes or where the existing scopes closed. And then every time I had a declaration, I would just simply put it into the most current table, which I referred to as current scope. And every time I had a use of a name, I could go into that current scope and do a lookup to see if I can find that declaration somewhere. And if we look at this, we can sort of see, right, D would go into the symbol table associated with this, so we'd have that thing here with a D in. But when I refer to D here, then that would be long gone because that table that D was in got shut down there. So we can probably write down the scoping rules for parameters and local variables. And here I'm not worried that the definition that we're going to write down doesn't necessarily take hiding into account. So for example, if I had something where I said curly bracket something 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 int x something 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 int x, and this might be illegal in some languages. It might be legal in some languages, or you could have something like that might be legal, that might be illegal, but it'll work regardless, just depending on how we set up our tables. So if we can probably agree that it would be illegal if I said int x here, right? I can't have two x's in the same scope. This is semi iffy. You might say, yeah, I don't like that because that really doesn't do wonders for readability, and that is true. But it's not a problem allowing it, because if you think about what we would do in this case here, we would attach a symbol table here in which x would live, and we would attach a symbol table here in which that x would live, and then that one would point here. So anywhere in here, x refers to that one, and anywhere out here, x refers to that one. So that's perfectly fine. Now, if I want to allow this sort of stuff, then I can simply attach a symbol table here and put X in there. And then we know for every set of curly brackets, we get that. So that's fine. We don't get any clashes, right? So what can we say about these?
I have a
That the
question.
yeah.
For that foo function that you did, how would you refer to the parameter?
For which function?
Foo.
Oh, you can't.
You can, right? Because you will always refer to the local variable, correct?
Yes. Well, there's no way of doing it. Why are you asking this question? Isn't this what you're telling people when you teach the class?
Yeah, no, I was just actually wondering, because you're saying that that will be allowed, but I mean, it wouldn't make much sense to have it that way since you will never refer to the local the parameter of the function foo.
No, but you could certainly have something. You could certainly have something that that looked like. So if I slapped actually if you so I'm going to erase this one again, but I'm just going to draw it here. So here and here we get that one, and here I get that one. Right? So that could be, I don't know, useful or not useful. I mean, you get to decide what the scoping rules are for the language you're implementing. I mean, it's not completely unreasonable to say you can't have two locals or a parameter and a local in the same scope chain that has the same name, because if you do, that's a source of confusion. In Espresso, I allowed this, so you can call everything the same thing, which means, let's see, yes. So that means, let me just show you something here. So I'm just going to delete this here again. So the following program is legal in Espresso. And I just did this because I thought it was fun. And it's kind of silly, but nevertheless. Right. So you do not have any freedoms for scoping rules, because I have designed the language and I've decided what the scoping rules are, and the scoping rules are such that this program is indeed legal. So no, you don't get a freedom. To quote Frank Sinatra, "You did it my way." So of course this is a rather silly program, but it does tell us something. It does tell us something about how we should design our name resolution, name definition phases, because this is a class name. This is a field name. That is a method. This is a parameter, and that is a local. So of course, none of these 5 different entities can live in the same symbol table, because then that would be illegal, right? You can only have one name thing in there. So we'll come back to that in a second. So what is the scope for parameters and locals? Well, for parameters, the body, unless hidden by redeclaration, and a local, it's from declaration unless hidden to the end of the enclosing block. There's there's a few little issues that we got to be careful about, which is for loops, and because you can define things in for loops, and also in switch statements. So this part here of opening and closing symbol tables and inserting things when you come across them, and looking things up as you come across name uses, is the second part of phase 3. So phase 3 consists of 2 different parts. A part that first goes and deals with class names, method names, and field names, primarily because they can be forward referenced, i.e. they can be used before they're defined. So we need to get all those definitions, all those declarations in place before we kick off the actual name lookup. And that's the second part. So the second part is looking up the use of all names, and also dealing with scoping issues for parameters and locals. And I forgot to tell you last time that your homework was to go and learn about the visitor pattern, because we are going to be using the visitor pattern. There's well, you can do a million searches to figure out about what the visitor pattern is. There's a link in the handout, and I think there's probably also some explanation about it in the video. But it's super simple to use. Maybe slightly more complicated to wrap your head around, but we'll get there. Right. So now let's look at classes and interfaces, but they work just like classes. So classes, fields, and methods. So what's the scope of a class? So in other words, where can I refer to a class? And here I'm not asking about Java scoping rules, because they're complicated, because we have packages and all this stuff. I'm just asking, visitor design pattern. What's in the design pattern book?
Mm-hmm.
Okay.
It's the thing I used to learn. I'll post a link.
Yeah, cool. Ben's posting a link to it. Where in an Espresso program can you refer to a class name? Well, basically everywhere. You can't declare a class private, and you can't hide it, and you can't nest them, and all that stuff. So what's the scope of a field? And what's the scope of a method? Well, both of these are the class in which it resides. So if we can agree on those being reasonable rules, then what we could do is we could try to set up a structure like this. So this is just a nice little symbol table, NV, and I'm actually going to call it, I'm going to call it class table. And let's just see, how do I fill that? Well, what if I just walk through the parse tree, and every time I hit upon a class decal, I throw it in there. So walk the tree. When meeting a class decal, insert it. So we get something like that. So that's easy enough. Now, if we think about what the tree looks like, it's a sequence really at the top, isn't it, of class decals, and then there's some stuff down here, there's some stuff down here, there's some stuff down here, there's stuff that looks more like a bunch of angels that have been hung from a tree. That wasn't intentional. And fields and methods live here. So if I associate with every class a table for fields and a table for methods, then every time I hit upon one of these, I can sort of update a global variable that tells me which class am I currently in. And when I find a field, I can throw that field into this class decals field table. And when I hit upon a method, I can throw the method into this fields or this class's method table. So what we're going to have here is something that points to a class decal. And in there, we have two tables. I have a field table and a method table. And of course, the field table is just, we're running out a little bit of space here. Actually, let me just take this thing here and move it up there. And delete that rogue one here. And that, and that, and that. And do it properly. So we'll do a field table here. And now Bennett's gone mad. He's talking to himself. So we get something that looks like this. And if I come across a field, so my field, it goes there. And what does that point to? Well, it points to a field decal. And very similar. In here, my method points to a method decal. Well, actually, it really doesn't, because we got to be a little careful here. Let's just go talk about that right away. Because what happens if I have something like this? So if I just inserted f into a method table, so let's see, let me make a method table here. Then we run into trouble, don't we? Because now we already have an f in there after having inserted the first one. So what we can do instead is I can say, all right, I'll put f here, but instead of putting a link or reference to the method declaration, and keep in mind, these are not necessarily method declarations. They could be static inits or constructors as well. But they can also, well, static initializers cannot be overloaded, but constructors certainly can. So what we can do here instead is we can say, right, with f, I'm going to have to put in I'll just put in another table. So now I'm going to just keep all the various different F implementations I have in here. So the first one, well, what should we index this by now? Well, what we could do is we could index by this type. We know that in Java the rules are that for all reimplementations the return type has to be the same. So we could index the first one by nothing, the second one by an I for int, and then the next one as a di for double int. And now I can have method declarations here. So we use the parameter signature as the key in the second table. So int is I, double is D, boolean is Z, long is J, the class is L something something something, semicolon, an array is a square bracket and then something. I think they're all in the handout, so you could see them there. There are a few more. Oh, float is an F. I think B is byte, S is short, and C is char, probably. So, what else is there to say here? Oh, constructors are called init, so that's their name, and a static initializer is a CL init for a class initializer. So when we insert constructors into this symbol table, we insert them with the name init, and we insert static initializers, we can insert them with CL init. It really doesn't matter. We could have inserted constructors with the name of the class, that would have been fine, but we then have to find something to call the static initializer because it really doesn't have much of a name, right? We could have called it static because you couldn't call your method statics, but this is just a way of distinguishing them. Nobody says this is the only way to do it. This is the way we do it in the project, but you can certainly imagine other possible ways of doing this. If you had a language where you were allowed to have different return types, then if these weren't all the same, then you'd have to put in the return type as part of that as well. So you might have to, in some ways, arrange things slightly differently. Right. So now let me just show you a visit method. So in general, maybe we can just do that over here for the visitor. For the visitor pattern, and you can find it in utilities visitor. Actually, let me just pull up the computer. It's probably easier just to demonstrate this. So what the visitor pattern is a reasonably easy, convenient way to traverse a parse tree. And the basis for this is this file here, visitor. And if you look at it, you'll find that it has an implementation that is public, returns object, and is called visit, and then the name of the parse tree node, and then the argument here is a parse tree node of that type. And the default implementation is to say, oh, just go and visit the children of this AE thing. So if you think about, without having looked at any of this at all, what is going to happen if I were to take the top node of the parse tree and just say, call the appropriate visit method in this file here. So the top is a compilation, I think, right? So here's the compilation. What would happen? It would say, oh, go and visit the children. And I assume what the children will do is it will call the appropriate visit on here. And they just keep visiting children for as long as there are any children. You see, when you get down to name, there are no children there, and there are no children to the modifiers and the literals and whatnot. So the visitor pattern, as it's implemented, doesn't do anything but just, it does a quick zoom through the parse tree without doing anything. Now, what if I went into this visitor pattern and changed something? Let's say, for example, I put a print statement in here that said literal, and then I set the visitor pattern loose on the entire parse tree again. What would happen? Well, every time I get into this thing here, it would say literal. Now, of course, going into this thing and changing it is not the way to do it. You just re-implement this one, and then you change the visits that you want to change. So if I wanted something that just counted the number of literals in a parse tree, I would write a visitor that would extend the visitor. So I could say something like class count literal extends visitor, int count is 0, public object visit literal li C++, turn null. That C will then be incremented every time I end up in a literal. Now, how do I glue all this stuff together? Because first of all, how do I make sure that I get the right one called in here? So for example, if I want to set this off from the top, I got to make sure that it's the compilation one that's visited. So if I have a reference to an instance of a visitor pattern, and I have the compilation, then it would be nice if I could just say to the compilation, hey, go and do some visiting with this pattern. And it turns out that that's exactly what I can do. So if you go and look in all of the AST nodes, they all have one of these visit methods that they all implement, and they all take in a visitor. And then you can see that on this visitor here, this guy will call visit compilation and pass himself. Now, if I look at what it looks like for name, then I would assume that it looks exactly the same here. It looks exactly the same up to here. And then instead of saying compilation, it would say visit name. Oh, look at that. Exactly the same. So it calls visit name. So now I can call visit on any parse tree node by simply passing it the visitor that I want to visit it with. Now, I got to remember to visit my children. You have to do that manually if you have children that you want to visit and you've re-implemented the visit from the original implementation in the visitor pattern. So there are two ways I can do that. I can go through the children array and visit all of those, and that's just visiting children, which we have right here. And since everybody extends AST, you can always call visit children, which just, as you can see here, calls visit on every non-null child. There is another way of doing it, and that is, of course, if we look at this, this method here re-implements visit literal. If visit literal in the original visitor pattern had children, the default implementation there would have just been visit those children. So in order to visit the children, if they exist, you can always say super.visit literal, super.visit name, super.visit compilation, or whatever. Or you can say visit children directly. Visiting children directly is slightly more efficient, but it probably doesn't matter. Right, so go and look at the visitor pattern. It's not hard to use. You only have to remember that if you want something visited, you re-implement that in your visitor. So let's try one here. Object visit class decal CD. Now, what do I have to do when I visit one of these? Well, according to this, I should insert myself into the, we should insert ourselves into the class table. So that's easy enough. So this is just class table dot insert or put or whatever, cd dot get name, comma cd. Then I can say current class equals cd, because now whenever I visit anything below here in the parse tree, I have a reference to the current class in which I can insert names of fields into the field table along with the declaration, and names of the methods into the method table along with the declarations. And then we just say cd.visit children, this. And return no. Now, what would you do for visiting a field? Well, you would say, right, insert into the field table of the current class yourself. Go visit the children. What do you do for a method? Well, you insert yourself into the method table of the current class. Go visit the children. What do you do for a constructor? Same thing. Static initializer, same thing. So there are just those 5 different things, 3 different kinds of methods: constructors, methods, and static initializers that can be forward referenced. There are fields that can be forward referenced, and there are classes that can be forward referenced. So we need to fill those 3 different tables before we do any sort of resolution. And that shouldn't be too terribly complicated to achieve. There are some sort of housekeeping stuff we need to do as well, but that's all described in the assignment and in the video. I do want to try to do I want to do another one. I want to do something about block, because this is now in the second pass through in the parse tree where we now deal with locals and variables. So again, it's going to be a visit method. It takes in a block. And what happens when I see a block? Well, I'm going to open a new scope. How do I do that? Well, I'm going to set current scope to be current scope dot new scope, and look in utilities symbol table for how that works. And then I can visit the children. And then I can close down the scope again by setting it back to what it was before. Oh, we should probably return a null here as well, shouldn't we? And now if we sort of just, I'm not going to write it, I'm just going to sketch it out here. What is the only thing I have to do when I visit a local declaration? Well, I just got to insert it into the symbol table, right? So it's just, and then visit children. There could be some children that need visiting if there's an initializer. What does the visit param decal look like? Well, exactly the same thing, except for there are no children that need visiting there. So even simpler in that case. Now, we talked about that last time. Oh, yes, I do want to talk about the thing that's going to be your nemesis throughout this project. It's the dreaded FUSA. No, it's the name expression. What is a name expression? It takes a name, returns an expression. It's an expression that represents the variable under that name. It's the expression form of a name. Well, they're all good. They're all good partial answers, and if we sort of mash them together, we're almost there, right? So it's something that definitely is an expression, right? So it's where you're using something as an expression. So in other words, something that might have a value. But it might not be a variable, because it could certainly be a whole bunch of other different things, actually. It could be a field. It could even be a class. So it's the, shall we say, use of a name as an expression. And that name could be a local variable decal. It could be a param decal. It can be a field decal. Or it could be a class declaration. So the question is, so if you have a program, I'll write a little program up here, and there you go, you see an X. That is a name expression. So where should I look to see if this name expression is declared in order to determine whether or not it's valid or not? I mean, if it's not the name of a local, if it's not the name of a parameter, if it's not the name of a field, and it's not the name of a class, then I'm pretty darn sure that it is not declared anywhere. The question is, in which order should I do that resolution? So should I look in the class table first, or should I look in the local variable declaration, or in the local var param scope chain first, or should I look in the current class's field declaration or field table? You know, what is closest? What's the right order to look this up in? Local first. I'm going to chunk in parameter with that as well, right? So because they're in the same well, they're in the same chain, aren't they? Parameters are just always higher up, so you'll always find the locals first. So look in the current scope. So if we didn't find them in the current scope, that means that there is no local variable and there's no parameter that can be seen with the name X. Then what? Well, then we should probably go for fields, shouldn't we? Because they're slightly closer than all the other classes. So 1 there, 2 here. Look in current classes field table. And then 3, look in the global class table. And if you don't find it in any of those, then it probably isn't there. Well, no, it isn't there. Then we're not even going to entertain any other offers. We're simply going to throw an error, right? So now we could. Well, no, that's all in the video, so I don't even want to say anything about that. Any questions on this sort of stuff right now? Otherwise, I think I want to leave that until you watch the video and started the assignment. Then we can come back and take some deeper look at it if necessary. It's not a very long chapter, and it's not particularly complicated either. And there are an awful lot of examples in there, so that's all good. If you look in section 6.5, that's some of the dynamic scoping stuff we talked about last time, in particular with the fact that there is no static link, we only use the dynamic link. So are we cool with this for now? You can sell anything to people who are sleeping. Right, so I have to remember to open phase 3 tonight. And I guess it's a little early to ask when can you have that done by. We'll take a look at that next week sometime. Oh, I did want to ask one other question. This right there, what is it? No, we'll set that next week sometime. Yeah, the due date. So what is that? It's the object, isn't it? Well, that depends on what the object is, doesn't it? It is an object, but which object? You're right, it is an object. The block you passed. And so Dennis says the block you passed, and Matthew says the visitor object. We are at an impasse. Which one is it? It's one of them, right? Not me. Why is it not the block? Well, it's not the block because the block is just a parameter, isn't it? But remember, this is always a reference to the object on which this method that you're currently inside was invoked. And since this visit block belongs to an extension of the visitor pattern, this here is a reference to the object representing the reimplementation of the visitor pattern in which this method belongs. So don't be confused about all these thises, because they don't always mean the same thing. Because when I go back here, for example, and we look at this one here, what's that this? And I think this is probably why the visitor pattern is slightly complicated, because it has this thing called dynamic dispatch, and it's because you're jumping from parse node to visitor, from visitor to parse node, back and forth, back and forth. So in this case here, this is not the visitor, because here the visitor is just this parameter. That's the one I'm using there. That this is a reference to this particular parse node, isn't it? So that just takes a little getting used to, but it is what it is. So let's see. Is there anything else I want to say about this? I really don't think there is much. Oh yes, well, no, we can talk about that next week if necessary. Go watch the video. There are two visitor patterns we have to do. We got to do the one that deals with the forward referenceable stuff, which is the classes, fields, methods, and classes, fields, and methods. Yeah, that's it. So I think that visitor pattern has a reimplementation of 5 nodes. And the one that does the locals and parameters and all the lookup, I think has, it used to be 13, I think it might be 14 now, because we came to the conclusion that a switch statement actually opens a scope. And we didn't think that until not too long ago, so I've sorted that out. But I can't remember if that's fixed in the reference compiler, so we might have to check that. But yeah, go look at the video, and then we will talk about it if there are any questions on Tuesday, I guess. Which means that we can now jump back to chapter 4, but I actually think we're doing really, really well on time. We are a little ahead of where we normally would be. Which means that I think we will stop here, and then we will just reconvene on Tuesday, and then we'll continue with the parsing there. Unless, of course, there are any objections. I didn't think so. They already started leaving before I even said all the good stuff. Well, now for the people who left already, right? Yeah. Right. So go and do something. Well, I was about to say go and do something else. No, go and finish your assignment and get it in. Please get it in before midnight, so that everything will be good and dandy. And just keep in mind, if you need help, I actually have another class today, so I will be MIA until sometime after 8. Otherwise, see you later.